Hello, everyone. My name is Jason Gerald, and if you guys are having problems hearing me at all, go ahead and type that in the chat so we can make sure to get that straightened out. But I will assume that you are hearing me. So yeah, I've been working on virtual reality for a long time now, and I'm just excited to talk about it with people and share my ideas and hear what others think about it. And of course experience of virtual reality, right? It's great to talk about it, but it's completely different to experience virtual reality than it is to just talk about it. So if you haven't had a chance yet, definitely find a friend or go to a conference, or you can pre-order your own right now. So if you can afford it, definitely do it. And my understanding is a lot of you are developers as well. So I'm going to be giving some kind of some tips for thinking about how to design virtual reality experiences. Okay, so I am going to go ahead and share my screen so we can jump straight in here. Okay, so I'll go ahead and get started. My name, as I mentioned, is Jason Gerald. Been doing virtual reality for about 20 years now, and a few years ago I started my own company, Next Gen Interactions, that focuses exclusively on virtual reality. So I'm in a pretty sweet place to be of being able to do this full time, and it's my passion in life. So I'm loving doing that. Sometimes 80 hours a week. Okay, so I've been doing this a while. I worked on a little over 60 virtual reality projects with over 30 organizations, some of which are listed here, ranging from academic institutions to startups to Fortune 500s, etc. But we're gonna move pretty quickly through these first few slides because I really want to get to the meat of the presentation. But I first want to say that here is what this presentation is largely based off of, is the book I recently released, the VR book, Human-Centered Design for Virtual Reality. And this was released back in late October, early November timeframe. And it really kind of summarizes the research that's been done over the years and put it into a fairly easily read format. Not necessarily a leisurely Sunday read, but definitely easier than going back and reading the research papers. The idea is that everyone on the team will be able to learn to this to kind of create a common language, not just within the team, but as you're talking with other developers. And my publisher and VWDP has graciously offered to give away a free book. So this is how it will work. Essentially, pay attention. This is also to encourage you to pay attention to the talk. But what you find especially insightful for yourself, or you have a great question that you have, go ahead and tweet that, and make sure at the end of the tweet to include the handle, the VR book, and also the hashtag VRWTB. And that way we'll go back later this evening and look at that most kind of insightful tweet or question, and my publisher will send you a free book. Okay, so we have actually another surprise at the end that you want to stick with us, because there will actually be showing how to get a discount. So all of you can be able to get this book at a discounted price. Okay, you can also check it out at the vrbook.net. Okay, so here I just want to say there's all these crazy devices here, that virtual reality is not new, right? Depending how you define that, can go all the way back to the 1830s, and really, computer generated display with proper head tracking and head mounted displays all the way back to the 50s. A fascinating, history, and we have a lot to learn from that history. We're going to go, this is a very brief history of VR because we really want to get into the meat of the talk here. So I'll continue on and talk about the most exciting VR tech for myself. This to me is not only the most interesting, but I'd also say the most essential piece of virtual reality hardware. And a lot of you might have some ideas what that is. A lot of people say head-mounted displays. Some people say have these different ideas. Is it the internet? What is it? It's this thing here, this crazy thing called the human brain, right? It's just crazy, massively parallel device, 100 billion neurons and thousands of connections of how those neurons are connected together. And in fact, those connections, what are called synapses, there's about 1 billion of those on average per millimeter of brain mass, right? And so a crazy number, 150,000 kilometers of nerve fibers. Just, in your brain, you have enough of those nerve fibers or connections between the neurons and such to circle the earth multiple times. Pretty crazy to think about. 6 degrees of separation. What I mean by that is that any neuron can really reach, I should say any neuron, on average, any neuron can reach any other neuron by only traveling through 6 other neurons. So massively parallel machine here. A lot of people try to compare the human brain to computers. That's comparing apples to oranges, right? Completely different. And, the brain does things very different than PCs. Computers are good at some things, brains are good at some things. Here we're focusing on the human element, the psychology of how we perceive things. We perceive things in all sorts of different ways. Most people in virtual reality focus on the visual element with head-mounted displays, but there's so much more of that. Of course, audio is extremely important, but other things as well. A lot of you, I'm sure, are aware that virtual reality can be a problem with motion sickness, right? That sense of balance, our senses in our inner ear gives us that sense of balance, and if those don't match up with what we see visually, motion sickness, for example, can result. And of course, physical touch. It's a huge challenge for virtual reality. We're doing that in some cases with specialized hardware and hacks and such, but certainly a long ways to go there. Proprioception is the sense of where my body parts are located. It allows me to close my eyes and touch my nose and know where my hands are in the world, so I can reach out and interact with the objects as if they were in the real world. Extremely important. Smell and taste, certainly a long ways to go there. That's occurring in the research labs, but not so much in consumer devices. That's messy, like literally messy, right? You're messing with chemicals and such. So it's extremely challenging to get in that consumer device. We'll see when that comes. And then multimodal is mixing these together in interesting ways. And definitely lots to think about there. And sensory substitutions, when we can't do one thing well, we can sometimes do that by a representation from a different modality. So if I reach out and touch something, but I don't physically feel it, well, at least I can like highlight that object, or I can feel the rumble of a controller, or provide some audio feedback and such. Okay, brief point here is that what we perceive is not reality. Virtual reality in some ways is no different than real reality, because as I see something out in that real world, what you perceive might be different than what I perceive. It very much depends what's going on in our head and our memories, on our past experiences, our mental model of the world, all those things. And so each perceives something differently. With virtual reality, you can see there's all kinds of processes here. This is one way to look at it. This is the iterative perceptual process, as originally defined by Goldstein, and essentially stimuli comes in from the world in the distance and then goes through various processes as it hits our sensory receptors. And then top-down knowledge influences what we see based off of our own personal experiences, and then we perceive and recognize objects in the world. With virtual reality, essentially, we hijack the human perception action system. Right here, we'll taking that, instead of the real world being out there, we're replacing that with visual stimuli, and then those actions are used as input into the virtual reality system. And then, of course, those actions change the virtual world. And here, human output is equivalent to virtual reality input. So depending how you think about this, input and output are the inverses, are in some ways equivalent to each other. Okay, I'm definitely not going to go through all this slide. The challenge we have when we hijack the human perceptual system is that it a lot of times doesn't quite work right, because we haven't perfected the technology yet. We haven't perfected the design yet. And human physiology is a tough thing to hijack. And if we don't do it right, then we can have problems. We can have adverse health effects, the biggest being motion sickness. And these are some of the different factors that contribute to these adverse health effects, all the way from latency in the system, if it's not fast enough, to if the screen is dirty, for example. These very things that are hard to control in a consumer world, those are system factors. Then individual factors, everyone experiences the world differently. And specific actions for you might make you sick, but not might make me sick. So it's not just a matter if you're more sensitive or not. You might be more sensitive to very specific things. And then what we do have control over is VR content creators and developers, is the application, the design of that application. So we, keeping the frame rate up high so that latency is low, or giving the user a sense of control, or matching that user's mental model of his expectations can influence if he gets sick or not. And lots of different tricks that we can, you are hacks, tricks, getting to the truth, whatever you want to call it, there's ways to reduce that sickness. And we may not ever completely solve it for everyone, but we can certainly drastically reduce it by thinking about these things. Okay, the point here is that there's lots of things to think about. It's not just one thing we need to focus on, and there's this design space of multiple factors we need to consider when creating our experiences. And I thought I'd briefly just mention the most currently the biggest challenge with virtual reality as far as adverse health effect is motion sickness. That's the biggest problem currently. It's not completely solved. And as I mentioned, it varies greatly from person to person. And users, we need to be very aware of this and stop at that first sign of sickness and, be well hydrated. And don't do this hungover. That's one of the worst things you can do. You'll have a very bad experience. And then in public exhibits at demos or whatever, definitely watch out for cold, sinus congestion, any, hygiene sort of issues. Now, as creators, we need to maintain that maximum frame rate. It's not just an annoyance that, it looks like a glitch in the system. You'll feel that glitch. You'll feel that little jolt. And if that, that can contribute to sickness. And if it happens, every 30 seconds or so, even if it's only very rarely, it still can contribute to that sickness. And make your interactions comfortable, not just comfortable from a motion sickness perspective of, doing crazy turns in the virtual environment so users get dizzy and disoriented, but also the physical interactions, not necessarily motion sickness, but do I have something called gorilla arm, which if the interactions are up high in the air, your arms will have fatigue over time. So there's lots of ways to think about, where do we put the interface? Well, I'll try to put it more comfortably in the user's lap or to the side or in what I call the torso reference frame. So he doesn't have to walk around and reach things from odd angles. And don't give those crazy roller coaster motions. Don't remind your users not to tough it out, because if they tough it out, it's only going to get worse over time. Duration of the experience is one of the biggest factors. And then, of course, wipe down the equipment periodically. Okay, now we'll move on to some of the hardware, and you can see all sorts of crazy things here. Head-mounted displays, that's what most people think when they think virtual reality, but there's other ways of doing virtual reality. In fact, you don't even need a head-mounted display. There's crazy rooms you can go into where the stereoscopic images are projected on the wall and the head is tracked, and the wall is almost, because your head's tracked, you draw the correct perspective for the users, like the wall's milled away and they feel like they're in the environment, not a room. The walls kind of milled away, similar to they happen in a head-mounted display. And the point here is also not all about the display. It's the input of how we interact with the world. And here's one crazy way. The Virtuix Omni, some of you might be aware of. This is an omnidirectional treadmill. It's called a treadmill, but in some ways it's basically a slippery surface, this low friction. You wear special shoes so your feet kind of slide along on the platform, and then there's something to hold you in place. Not like real walking, it's definitely not there yet, but it's close to it, right? It's approaching that, and it's a great way to navigate through the world. And my understanding is you guys will be able to see the video, but maybe not the audio. So I will attempt to describe what my friend Jan did here with the Virtuix Omni on Shark Tank a couple years ago. And he does a fabulous job of explaining this, probably better than I can, but since you can't hear the audio, I'll explain it. Basically, if the zombie's coming at you, you can go ahead and, physically turn the other way and run like hell, right? It's sort of a visceral response, which virtual reality is all about visceral communication to the user that is extremely hard to describe. You have to experience it in yourself. So this is an example of bringing your body into the world. Now, with all those crazy devices, there's sort of ways to think about interacting with those, with the world. And here I divide them into hand interactions or hand input devices and non-hand input devices. And things like the treadmill is down at the bottom, right? You can do some things that has that sense of proprioception, which is the sense of where your body parts are located. And it has these other sort of capabilities that can handle. And the point here is not to go through all of these in this talk, but the point is that no single input device class has all properties, right? There's advantages and disadvantages of each. So we really want to think about sort of this design matrix here when we're either selecting hardware to use, or if we have a specific piece of hardware, such as tracked handheld controllers, then we need to design things that take advantage of these capabilities that we have. So lots to think about there. And we will move on to what I think is the most important input devices. So of all those things all those crazy devices you saw pictures of, or the different classifications, there's one that I would argue is essential for all virtual reality experiences, no matter what it is. And that is the human hands, right? Hand tracking technology, whatever device it is, whether it's a camera-based system or a handheld controller, those technologies are just mediators that bring the hand into the virtual reality environment. And if you actually look at the brain science behind it, a large proportion of our sensory and motor cortexes are devoted to the hands, right? Because in the real world, that's how we've been able to, evolve through millions of years. It's so important of how we interact with the real world, and thus it's important in virtual reality as well. And so all of these great, amazing new consumer level hand track controllers coming onto the market, it just completely changes the game. It takes VR to this level, that takes presence to a level that just can only be explained by experiencing it. And that is what I'm so excited about. Now, another way to think about how we interact with the world is what I call interaction patterns, which are kind of groupings of different, more specific interaction techniques, but very similar in concept. Now, here I have sort of 5 groups of interaction patterns: groups of selection interaction patterns, groups of manipulation patterns, groups of viewpoint control, which is essentially navigation, but also includes things like scaling the world; indirect control, where we're similar. Direct control is not always the best case for virtual reality. In some cases, you want to, if you want to go to the library to check out a book in virtual reality, you don't have to walk to the library. You want to access that information more indirectly. And of course, a compound pattern. And then these patterns can be further broken into more specific interaction techniques. And I'll be showing some examples of some of those things. So the first thing we do when we are able to bring the hands into the world is we kind of do one-to-one tracking of the hand. So here's a game we created a few years ago. This is back in the days of the Oculus GK1 days, along with the Razer Hydros controllers, which are physical hand track controllers that we bring in the environment, and they have buttons and a joystick and such on the controller. But the point is, now you have head tracking with the Oculus Rift, and you have hand tracking as well. And by bringing the hands and the head in the world, just adds this visceral level of body communication, right? This is Paul Milenick here. I'm aiming the gun at. Paul Milenick is the president of Digital Art Forms that's been doing VR for years. But now, because his avatar's in the world and you have those direct hand mappings, is that he doesn't have to think about, oh, which button was the surrender button. No, he just does it automatically. It's just sort of this natural body language. The developers might not even consider doing that, of what a surrender interface was. It's just this natural communication, and social VR is so compelling because of this sort of natural, intuitive body language that we have, even when we're only tracking a couple points, the hands and the head. So incredibly compelling. Here's a video also we did with Digital Art Forms. This is a way to reach out and select objects in the world. So a pretty straightforward implementation of grabbing objects and grabbing objects in the world and putting together a puzzle. And that did not play. Let me try that again. There we go. So you can see we're just reaching out and picking up these objects and placing them into the sort of 3D brain puzzle. And we can also rotate the table with the left hand there. And these objects sort of snap into place when you get close, because precision is one of the challenges within virtual reality. And we will skip this slide because the point of this slide is some points on providing audio feedback. Basically, you pick something up, you can easily provide some audio clues to the user of what that brain pieces for. And we found that teaching this to kids, they would pick up normally this concept, neuroscience thing that's kind of normally difficult to teach. Now it's learning by doing, taking this normally abstract concept. And we did this with kids, and it was amazing. They would pick up these, understand what the different brain lobes, what those brain lobes do, right? The occipital lobe does, is about vision. They would get that within minutes. Amazing that they just wouldn't be motivated enough to do in a classroom. Here's a pointing pattern, and that you can just think about pointing off into the distance, similar to a laser pointer that we have with, the same way that we might, or a similar way we interact with our TVs, right? Or if you're shining a laser out into the distance when you're doing a PowerPoint presentation, for example, right? But of course, we can do cool special effects here, such as aiming lightning at the enemy zombies here to protect our friend Fred here that we're protecting with this game, Zombie Apocalypse. Also, we created with digital art forms. The idea here is that the zombies have brain deficits. They have problems with their brain, and if he's limping along, then we need to figure out, okay, what is wrong with him, pick the correct, quote, ammo, and then shoot some ammo at that character so that we can match up that brain deficit with the proper brain lobe or the ammo. Okay. Another thing you can do when you track the hands, instead of just putting the signifiers of what does what on the controls, these are just simply bringing a visual representation of the Razor Hydra directly mapped to the hands. And so we are not doing finger tracking here, unfortunately. Maybe someday we will, but not yet with this system. The hands are close enough. At least you can physically feel where that button is. And also, I want to point out that you don't want to just put, the A button, B button, C button, D button. No, you can change these. In fact, even your interface can change. And so, dynamically, and you don't necessarily want to do that because you want the user to get, accustomed to one button doing one thing in most cases. But the point there is that the design space, we can do all these things extremely easily. And of course, you want to be able to, they're nice because you can hold the controllers down to the side, so it's not always in your vision in the way when it's attached to the head reference frame. But you can look down at your hands and see those signifiers of what does what when needed, but doesn't get in the way when not needed. And of course, you can also turn these on and off so that, as you become better with the user, you no longer need those signifiers, and just completely turn them off as users get more familiar with the interface. And of course, we don't necessarily need to bring in the arms. In fact, a lot of VR demos you see skip the arms because it's difficult to do that really well. And so we don't necessarily need these realistic arms. It depends, what you're going for. Depending on your design goals, you might not be going for a realistic application. So on the left, we have a game where we have no arms. We just have a representation of the hands, and you pull a trigger, and it does again with the Razor Hydra, it does a pull gesture. A point gesture. Or to pick up the basketball, you reach out your hand and you pull a button, and that's a grab gesture, right? This is sort of that direct hand pattern, selection pattern. And then on the right, the point is that those sort of spherical or cylindrical red things in the foreground, those are the hands. It turns out in VR, you don't even necessarily need to match the hands. It can be sort of this abstract representation of your hands, and it might be a little bit weird at first, similar to the way that not having arms is a little bit weird at first, but you quickly realize if you have that sort of direct mapping of the hands to these other abstract objects, that you just get accustomed to that, and it's almost like those objects become your hands even though they aren't your hands. Okay. And then we can do different funky techniques. This is an example of an image plane pattern where we're looking off in the distance, and if we have some form of hand tracking, then we can look up and close one eye, and one hand, that whatever's off in the distance, we can now intersect the ray from our eyes through a finger, or in this case, between the fingers, and anything that ray reaches out into the distance, or that image projected onto your hand or between the two fingers here, is the object to select. So we put our fingers around the object that we want to select, then we either push a button or provide a voice command saying select, and then that allows us to select objects at a distance. So an example of one way of beyond sort of the obvious just reaching out to grab something, but reaching at a distance. And then we can bring in, of course, 2D traditional widgets. Here you can see we're bringing in some tools. This is a cave system like I talked about earlier, where the head's tracked and it's you have 3D glasses and the walls kind of meld away if you were actually from my perspective there looking at the walls. But the point here is that we could bring in existing 2D widgets from a 2D system and interact with those widgets from within the virtual environment. Not the ideal thing to do in a lot of cases, but the easy thing to do, right? We can easily bring in a calculator application, for example, without having to write that, I want to do a quick calculation. I don't want to go write, spend a day writing a calculator application for virtual reality. I want it now, and I can simply project a wand, which is not shown here, but you can imagine that a pointer or some sort of virtual wand reaching out from my hand, physical wand there, being able to project that that pointer to a mouse cursor that controls the 2D environment. We can also take some of those metaphors and specifically build it for virtual reality. So in the top left, you see sort of a basic 2D elements attached to the non-dominant hand. And attaching these panels, these virtual panels, to our hand, some of the applications like Tilt Brush does a great job of doing this. It's naturally in my non-dominant hand, and you're able to intuitively reach interface elements very easily and very comfortable, because the non-dominant hand sort of acts as a reference frame from the dominant hand to precisely choose items. So those are sort of some straightforward 2D items on the left. Then on the right, you see some more interesting sort of dials, because now we're sensing rotation of the hands. We can do twist-like gestures, although we found that can cause wrist strain over time. So instead, we do a full circle, sort of like a pie menu within some of you may be familiar with from the 2D world. We just kind of reach in and then perform a circular motion with our arm to select those different triangular areas. And then on the bottom, we have a color cube. Color spaces are often defined in sort of a 3D color space. Well, we're in 3D. And so let's create a color cube instead of a 2D color with an additional slider. And so that, I should say the yellow, what we call chopsticks, are representations of the hands. That's an abstract hand cursor, essentially, in 3D. So position and orientation of the hand is directly mapped to those controllers with a more precise pointer with the chopstick sticking out there that allows you to more precisely choose things than if you were using a larger hand model. So that's sort of a combination between a pointing pattern and a direct hand selection pattern. Okay, another cool thing that I'm really excited about this pattern is the 3D multi-touch pattern. Very similar to 2D multi-touch, similar to, if you zoom in on a map, you do a pinch gesture. Here you're doing it with your hands instead of fingers, although you could conceivably do it with the fingers if we have more precise and accurate finger tracking. But think of, reaching the arms out and putting your arms around something and then pulling the hands apart in order to scale the world. But you can also rotate the world right now, because we're in multiple dimensions. This is definitely not doesn't have high interaction fidelity. By interaction fidelity, I mean something that is like a real world interaction. Right? But high interaction fidelity isn't necessarily the goal. It depends upon, what the project is, what we're trying to do for the environment. If it's abstract data visualization, this can be very appropriate. So we've used this for emergency preparedness, the medical visualization, make VR, and surprisingly, the arms don't get tired with this. A lot of these interfaces, when the interface is up high, advantage of this is you can grab the world and pull it down in your lap, or work with your arms to the side and rotate it so that you can work comfortably with your arms. And surprisingly, you wouldn't think this, but this dramatically, the sickness isn't a big issue. The reason for that is because you have multiple reasons. One is you have a sense of control of direct you're grabbing the world and moving it towards you. So you're not doing this abstract connection of moving the world, but you're also, if you think about it as manipulating the world as an object, similar to a real world of, if you open up a really large door, just because your visual field when you're close to that door doesn't, you're probably not going to be sick because you realize that door's moving, you're not moving. And so if you think of the world moving instead of you moving, there's less vestibular visual conflict and thus less of a sim sickness issue. Okay, so here's an example, again, with a game from Digital Art Forms of how we interact with a sort of, let me try that again. So this is another level that we briefly talked about. You can see the person has his arms from this really kind of third-person exocentric view of looking down at the world, but he can also, so he's grabbing the world and sort of pulling and pushing the world away from him. So again, if you think about this as manipulating the world as an object instead of you moving through the world is one way to think about it. And there he just brought it closer to him by doing sort of that 3D arm pinch gesture with his arms. So he's bringing himself down to a first-person perspective. Here's another example of 3D multi-touch applied to medical visualization. Again, those 3D cursors are sort of a way to of grabbing the world that represent your hands, right? In sort of that abstract way that don't include the arms or even look at your hands. So these are sort of some old school controllers, very similar to the Vive, HTC Vive, or the Oculus Touch or the PlayStation controllers. And there you can see a panel that I discussed earlier of being able to, you know, that's held in your left hand essentially. And then we have something called the clip box where we can kind of useful for information viz or medical visualization like here, that we can basically clip out the areas that we're not interested in or render that other information in different ways so we really can focus on the area of interest. It's the same thing used with the application Make VR, created by Digital Art Forms and published by 6 Sense. And I think we have a brief example of that. And so this is a full CAD package where it's actually a CAD engine. You can see those 3D cursors in there, you recognize, you see the recurring theme. And it uses the 3D multi-touch pattern so you can zoom in, but also, you know, being able to build worlds, either objects or even the world around you. We found we can go up to, you know, 4 or 5 hours, surprisingly. I was surprised by this, that you could go that long without the arms getting tired, because you sort of naturally, you know, work in comfortable positions as you bring the world to a comfortable working position. Okay, so you get the idea. Oh, I should say that it's a full CAD engine, so you can actually do like, you know, actual Boolean operations and such. Okay, so what's common to all? What's common? I kind of gave it away there. I wasn't supposed to jump ahead to the slide. What's common to all VR development? Well, you know, all the projects I've worked on, they've all been unique, right? Every project is different, but iteration is the one common theme. And so iterate, 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 and fail, fail, fail. You will fail. If you're doing virtual reality, anything beyond bringing a simple model into the environment, you just have to experiment. You also have to get feedback from other users other than yourself. For example, you'll probably, as you continue to develop these systems, you will grow immune to sickness, right? And so you really need to get, you know, users that, you know, who's your target audience, right? Put together those personas and figure out, is your target hardcore gamers, or is it sort of the common, you know, the common user that maybe isn't familiar with VR? And, you know, that's important for usability as well, right? You want to make the interface, it might be complex underneath the implementation, but the interface from the user's perspective needs to be as simple, as straightforward as possible. And so lots of steps to think about here. Here's one example that we're working at NextGen, is how can we more consistently provide feedback and help companies evaluate what they're doing, right? So, you know, you can do expert guidelines-based evaluations, which, you know, range from all the way from the basics, such as are they doing a really high frame rate versus is the interface, you know, located in a comfortable position around the user and the, you know, and the torso reference frame, for example. And also some of those things you might not be doing well, but who cares? Maybe that's not a priority for you. That's just not something that the user commonly performs. So it's not just a matter of what you're doing well, but prioritizing what is the most important thing for your specific project. Then we can move on to formative usability evaluation, which uses things like think out loud protocols of the user just saying out loud what he's thinking, there's what he's doing, all the way to just purely observing, not talking to the user like you see in a lot of demos of, hey, go do this now, that you're screaming at the person through the headphones. No, in the real world is going to be very different when we get these systems out in the wild, and, you know, we're not able to tell them when there's a problem of how to use the interface. And so very different than the demos that we see at trade shows, a big challenge. And the comparative evaluation is a more formal user study that's doing statistical analysis and such, very much focused on the numbers, right? doing statistical analysis and such. Okay, so in summary, I'm really excited myself about these tracked handheld controllers because that so takes presence, not just presence, but the ability to control and interact with the world to an entirely new world, but only if designed real well, right? This is, this talk, the intent here is to really get the point across, to really think about the design. Designer is so important for virtual reality. If you do you do a bad web page interface, it frustrates users. You do a bad VR interface and it gets people sick, or, they all the other adverse health effects, such as if you punch something and you don't have some sort of warning grid to come up, you might punch something physical in the environment and hurt your hand. All sorts of things to consider. And that there's no universal answers. Every project's unique, and selecting the devices or building your game or your experience around the available your target devices as well as your target audience, knowing what understanding your users, and selecting patterns, right? I showed examples of some patterns, but certainly other patterns to think about, and understanding the trade-offs of all these things and where and what those different options, what is appropriate. And of course, iterate, and failure is your friend. That's where you're going to learn best. And even though failure can be painful, it's not so painful if you're having fun, right? So definitely have fun when you're doing all of this, and fun whether that's in the real world doing this development or it's within the virtual world, right? Any sort of reality, real reality or virtual reality. Otherwise, what the heck is the point of all this? Okay, I mentioned at the beginning of the talk a discount for all of you attendees here. If you go to the vrbook.net, there'll be a link to my publisher's site there at the bottom of the page, and you just enter that discount code, 15% for the best 16, and you will receive your discount. And also, if you continue to tweet here, we'll be looking at those tweets here in a little while and be selecting a winner to have my publisher send them a book. Okay, well, we'll now move on to questions. Let me go ahead and change the screen here. And let's see, I believe, I'm not sure if I'm supposed to hit the question icon or not. So I'm not going to, because I'm afraid that's going to end. But if a moderator's on the line and I need to hit that questions icon, then please let me know. Otherwise, I'm going, all sorts of great questions here. So questions. Human hands are the most important input. Yes. It just takes that to the whole new level. And gloves, absolutely. There was a slide I took out of here because there's so much to talk about. But one form of a glove was called the fake space pinch glove, taken back from the 90s. If you ask any sort of virtual reality gurus that have been around a long time, these gloves are one of their favorite input devices that basically you could do this pinch sort of gesture, and it would basically, the implementation was that it would close the circuit, so there'd be an electric signal, and when it sensed that you were touching the two fingers together, it would be equivalent to a button press. And so as a result, you would have this sort of physical feedback, like pushing a physical button, but not have to hold a controller. Now that evolved into what we have the controllers now. I showed in the medical application that crazy input device called the Space Grips, which evolved out of those fake space pinch gloves that then evolved. The difference there is that was $10,000, right? So not consumer friendly, but that evolved actually, that evolved into the Razer Hydra controllers, the physical controllers, which then evolved into the 6-cent stem that's going to be shipping in the next month, which are very, very similar to the Oculus Touch, PlayStation Move, and the HTC Vive. Now, those gloves, there was one crazy slide that did have a glove. We're working with the Waterford Institute of Technology that's working on a glove, but kind of looking, it's not really even a glove anymore. It's sort of a crazy hybrid solution. But other gloves, absolutely. They're in some ways similar to Leap Motion or other forms of hand input, right? One is that you're physically wearing something so you can have more consistency. Gloves, have the advantage, depending how they're implemented, that you don't have line of sight issues, right? That's one of the challenges with the Leap Motion is, if you don't have the correct lighting and stuff. So in some way, gloves have advantages and disadvantages. If you remember that matrix that I showed, that there were, no single input modality was perfect. So that's certainly one of them, but then you have to put on the glove, right? That's a disadvantage. So advantages, disadvantages. One of the challenge why they switched from the fixed space pinch gloves to that evolved into handheld controllers is because there'd be a lot of hand sweat having to have the hands on. So at conferences and stuff, it'd get pretty gross, but really maybe a better solution is more breathable gloves. And as far as haptics, yes, so haptics, there's all sorts of different forms. Well, in some ways, we have very basic haptics of the rumble in a controller, or the 6th Sense. For those that played the HTC Vive, one of the best, it's the simplest thing that you reach the hand up. The first demo is you blow balloons out of the controller. You push a button and the balloon goes, but you feel that balloon by this very subtle, rumble of the controller, and it's like the perfect use case for if you could call it a use case of the coolest experience anyway, of like, it just feels so real. So that's one form of haptics. There's also passive haptics. If you're doing location-based entertainment, you can put a physical prop that is low fidelity, like a piece of styrofoam that matches a high quality, high fidelity visual, something in the head mounted display, and you can reach out and physically touch that if you line up the physical prop with the visual prop, or if that physical prop is touched, right? Or handheld controllers, you could say, is kind of a form of passive feedback, because if you have a sword or a gun, virtually, it's very different if you physically feel that in your hand. So kind of an advantage of hand track controllers, if that sense of touch is important. But as far as active haptics, that is certainly done on the higher end, and but challenges with that. If you want to, walk around the room, it's a little bit more difficult. People have done it. You can, attach the haptics to the body instead of the real world, so you're not going to get, true force feedback. But there are crazy gloves like there's gloves with exoskeletons, right? So I can squeeze a ball and it feels like, I get some resistance in my hands, or entire exoskeletons of the body attached to the real world. So, I could arm wrestle a virtual character, right? Or an avatar located at a different location. So certainly doable, but at the consumer space, further out, but hopefully not that far out. I mean, you're exactly right. The Manus VR Glove 1, there's quite a few of those out there. You can add the sense, those, so on the tips of the fingers, you can add a little rumbler to kind of give the sense of haptic feedback with those gloves. Okay, so 360 video. Yeah, 360 video is really funny. From the research community I come from, we never thought about 360 video. It came as a complete surprise to us. We just thought, I guess because a lot of us came from computer graphics, right? That we had to create it from scratch. But man, I was at the Digital Hollywood conference here about, I don't know, three or 4 months ago now, and it's Hollywood. It's not a VR conference. It's just general, a lot of general, whatever, digital content, and like over 50% of the conference was dedicated to virtual reality, immersive film. It was amazing to me that how excited they are about that. And so design considerations for that, not as much as my area of expertise is this more interactive versus passive type of experiences, but there's definitely design considerations, for example, with stereoscopic versus monoscopic. Everyone wants to go to stereoscopic, but stereoscopic, that is an image for, the left and right eye, is when done well is amazingly compelling, but it can be extremely difficult to do. And so some cases it's better to go for the more basic monoscopic, even though, you don't get that sense of depth as well, but it can be, mono is better than bad stereo. And so, as the stereo displays and calibrations and such continue to improve, then we'll move more and more to stereo. But one of the challenges, and going kind of beyond 360 film, is when we get to light field. So I can actually, and we also, we have Samsung Gear VR Tracked and such, our position tracking, which, even Cardboard will get there because Google's working on their technology to the motion tracking, so I can get parallax, so I can look around objects. So that is certainly going to be cool. As far as the design implications, there's, questions of how close do you put things close to the user. It can kind of be weird if it's monoscopic, but also things really close to the user, even if stereoscopic, can cause eye strain and such. Also, if you look down at the environment, stereo doesn't work so well in most cases, because you look down and there's a basically the or you twist your head like this. Basically, the stereo effect is no longer works, and so the similar effect happens if you look down. The stereo illusion is kind of broken. So a lot of times you want to either fade out the bottom and the top, or you put some geometry there. Okay, so next question: is there a way to zoom in and zoom out without using the hands? Well, you definitely can. So, I mean, you can do anything in VR, right? Something that you really want to experiment with, because to me, it's kind of surprising that you don't get a lot of motion sickness even with you using the hands. If you don't use the hands, say it's more of a joystick, you're probably a little likely to get more sick. But something I haven't personally tried, right? So I have to hold back, and instead of jumping to judgment, is figuring out, experimenting. And so you certainly can, push joystick to scale, for example, would be one way, or jump. So not a smooth scaling, but maybe there's a HTC Vive demo. I forget which one it is, but you kind of point out an object, then you jump to that location. But you don't just teleport to that location. You actually teleport and become small, and so that doesn't cause sickness, right? It might be a little bit disorienting. Again, there's trade-offs, but there are trade-offs. But one thing to you don't get really sick at all when you do that, although you might get a little disoriented. So that's, I think, a great way to do a scale. So kind of pre-planned scaling or teleportation. And that's when I talked about the interaction patterns. That was one of the interaction patterns listed under automatic navigation, right? Because you're kind of saying, I want to go to that location, now automatically navigate me there by teleportation. Okay, resistant harnesses for touch. So I think this is probably the haptics question that we talked about. And let's see. Yeah, that was so I think I kind of answered that, but go ahead and feel free to ask that question again if you mean something more specific. Oh boy, I like this one. What virtual rotations are working and accepted by the brain? So this is something I'm experimenting heavily with myself. It turns out that these virtual rotations, accelerations are bad, but virtual rotations can be bad as well. Linear velocity and moving forward actually is okay, even for immersive 360 film. But it's the accelerations of the viewpoint that are typically more of a problem. But virtual rotations tend to be a problem as well. And so, yes, there's things we're experimenting with. If you look at like Eve Valkyrie, for example, there's a cockpit that's a stable virtual, something stable relative to your vestibular system. So there's less conflict of what is stable and what is not. So we're playing with similar sort of what are called rest frames with basically putting user interface elements and basically clues to the user that if you turn, some things are stable in space and some things move virtually. And a lot of unknowns about that we're still experimenting with. We don't have answers for yet. Oh, you want the AR book? So boy, I don't know. I'm pretty burnt out. I was spending 80, 90 hours a week writing this book at the VR book, but the AR book is definitely further out, but it's going to come closer together where some of these concepts, I gave a talk once on interactions, and then I was moderating a panel on AR interactions, which I'm not as much of an expert as on the VR side. And I realized out of those interaction patterns, at first I was like, well, these seem very specific to virtual reality. But after I started looking at those, I thought, wow, most of these, implementation might be a little bit different, but some of these patterns, maybe not the 3D multi-touch patterns, but a lot of those other patterns are would, like I said, maybe slightly different, but the basic concepts could apply to augmented reality. And so I think a lot of this applies, definitely the perceptual issues, mixed reality. One form of mixed reality is a video see-through instead of optical see-through head-mounted display. So you're seeing the video that comes through. I think for mixed reality is in some ways closer to virtual reality than it is with augmented reality. Some of the similar challenges, motion sickness is a similar challenge with mixed reality in some ways. Optical see-through head-mounted displays is harder to do to match the visuals with the real world, but you don't really have issues with motion sickness. So yeah, that's all sorts of answers to that questions there. Okay, you want to try the telesuit and Tesla suit. I haven't seen the Tesla suit, but yeah, for sure. I think what you mean by that is the exoskeleton. Yes, I've tried sort of larger robotic devices that are, very, still in the development stage, but definitely very cool. You can imagine if you're doing telepresence where you're controlling, a large robot remotely and you feel the objects, locally. Foveated rendering, absolutely. So once eye tracking, I think eye tracking applications are going to be the uses. Right now, you go see demos and you shoot lasers from the eyes or whatever. That's okay, but I don't think that kind of gets the point across of what eye tracking does, but I think an actual use is going to be more subtle, such as proper foveated rendering. The users aren't going to really notice, but it's going to speed up time. So absolutely. And to do heat maps, to know what users are looking at, like when you're designing your applications, to know, what users pay attention to, and, whether you're modeling the real world or just to find out in your game, are going to be huge. And light field rendering, as I was saying, that's Google's working on those things, Stanford's working on those things. Really realistic. The challenge there, my understanding, is the storage. It takes a massive amount of information. Oh, definitely a macro revolution. Things are happening so quickly. Like light field rendering, I thought was going to be a few years out, but now, it's already happening now, right? People are able to do it. It blows me away how fast it's happening. Or the convergence of AR and VR, that's happening further than I thought. I thought that would be further out. Okay. Okay, sometimes it seems to me automatic learning skills could provide the smoothness required in VR controls. So that goes to that automated pattern. For example, with the one way to do it is the teleportation, but another way is to point at it and then move the person visually to that location. You generally want to stay away from acceleration, but if you move them that way with a constant linear velocity, then it actually works pretty well. Other things, if passive experiences, if you want to be very careful with the accelerations, because the person's expectations of what will happen, if they're not expecting this crazy turn coming up, then it happens, but they're not expecting it, can be a problem. So you attempt to do linear velocity and stuff, straight ahead movement. But you can do things, for example, with leading indicators. I almost never see this with immersive film of the viewpoint changing, but what you can do is that you can provide what's called a leading indicator of sort of this airplane or this car or whatever in front of you that turns, a quarter of a second or half a second or whatever before your personal camera changes, right? So you're just like following a car, and that gives the user a hint that, wow, this car is turning to the left, and if the person understands he's turning to the left, so I'm about to turn to the left, the expectation is you're going to turn, and thus it reduces sickness. So that's a way to reduce sickness with the sort of automatic. I'm not sure if that's your question about automatic learning skills, but I do think for learning, being active in the process of learning instead of downloading like in the Matrix movies, but being able to reach out and doing by learning through virtual reality, I think is going to be extremely compelling. Oh yes, perception neuron. So we have someone asking here about perception neuron. So I just tried the latest demo from them at the Game Developer Conference on Thursday, so just a couple days ago, and they're now mixing high-end camera-based tracking with their inertial tracking, and it's done so well. So hybrid tracking is really the way to go. I'm so excited to be seeing them doing this, and others are doing that as well, right? We're developing some stuff in-house as well as WorldViz is doing that, and essentially mixing inertial sensors with camera-based system, or the 6-sense STEM has inertial sensors, accelerometers, and gyros within their units in order to decrease some of the distortion inherent in electromagnetic tracking. And so the perception neuron demo I saw was like five tracked users of the hands and head, but you could also track more of the body. So definitely the way to go. Okay, what are the best example use of sound spatialization in cues? So sound is not necessarily is not really as precise as vision. Like vision, we're able, in hyper acuity, we can detect super accurate down to arc seconds, right? So we have a long ways to go before we reach hyper acuity with our head mounted displays today, right? Sound is really good of, you know, situational sort of awareness of something's behind me, right? I can't see it because I don't have eyes in the back of my head, but I know it's behind me. So for example, we have this game we're creating, we have the bad guys shooting lasers at you, of course, right? You got to have bad guy robots with lasers. And when they're shooting at you, and you pay attention to where that's coming from, it can be very, it's like, where's that coming from? You're looking all around and then, you know, it's fast paced. But once the user realizes that the audio is spatialized, they have a much better idea of, oh, he's coming, you know, maybe not precisely, but from the right. So I can turn my head real quickly and then more precisely see where that laser is coming from. With the eyes. And so I think I briefly mentioned sensory substitution. If you can't do something with sort of real physical feedback, well, you can at least provide some audio to provide a cue that, you know, I touched or I bumped into the object. And so, yeah, sound is huge. Those are just a couple examples. There we go, Tesla Studios. I will definitely check that out. Can you see a future where one in architectural modeling? Yeah, absolutely. So Make VR that I mentioned is similar to that, but actual architectural models. Oh, absolutely. So I was just talking to someone this morning about this. I'm at the IEEE Virtual Reality Conference today, and that's exactly what they're working on doing. And there's huge challenges there because actual CAD, Make VR uses an actual CAD engine, so we can, you know, have those things. But other architectural, more focused applications, it's you know, it's not just polygons. There's a whole lot more information there, and often it's more detailed polygons. So getting them up to a high frame rate. I think Autodesk is working on some of those solutions. So yeah, absolutely. Okay. And we are done. 2:55, which I hope I didn't go over. I think I was supposed to end 5 minutes early. But thanks, guys. That was very I always, like I said, I love talking about this stuff. So thank you so much for your time, and I hope you got something out of the talk.